Hello student, hope you all are well. Last session we discussed about the proof of Bernoulli theorem. Now I will discuss about the application of Bernoulli theorem. Bernoulli theorem says energy per unit volume before means at the point initial equal to energy per unit volume after the final point. According to equation of continuity, if area A2 is lesser than A1, then velocity V2 will be greater than the velocity V1. So to balance the Bernoulli equation, P2 will be less than P1. Means if at any point velocity is higher, then pressure will be low at that point. We can write the Bernoulli theorem in general as the total energy, that is pressure plus potential energy plus kinetic energy at any point will be always constant. Now, if V1 and V2 are 0 means fluid is on rest, then kinetic energy will be 0. Hence we can write P1 minus P2 equal to rho GH, where h is the difference between the two heights h2 minus h1. There is some limitation of Bernoulli theorem. Bernoulli theorem does not hold for non-steady or turbulent flow. It cannot be hold for the compressed fluid and for the viscous fluid, that is, loss of energy due to the internal friction between the different layers of the fluid. Calculation of speed of efflux Torricelli law. Efflux means fluid outflow. This was discovered by Torricelli that the speed of efflux from an open tank is given by a formula identical to that of a freely falling body. Let's consider a tank of area A2 with a hole of area A1 at the height of Y1 from the bottom and the pressure P on the surface. Then from the equation of continuity, V1 A1 equal to V2 A2, or we can say that the velocity of fluid going down in the tank is equal to the ratio of area A1 A2 with the multiplication of velocity of fluid coming from hole. Now applying the Bernoulli equation, we get PA plus half rho V1 square plus rho G Y1 equal to P plus half rho V2 square plus rho G Y2, where the PA is the atmospheric pressure at the hole. But as we know that A2 is very larger than A1, then from V2 equal to A1 upon A2, V2 will be nearly equal to the 0. That is, at right side, kinetic energy is almost 0. Or we can write half rho V1 square equal to P minus PA plus rho G Y2 minus Y1, where Y2 minus Y1 is H. So from this we can get the value of V1. Here V1 equal to under root 2GH plus 2P minus PA upon rho. Here one mistake is there. Here P2 is the P. If the tank is open to the atmosphere, then P equal to PA, and then V1 becomes a under root 2GH as the free fall body equation. Now case 2, when P is very greater than the atmospheric pressure PA, then we can ignore the first term 2GH from the equation. That is, the speed of efflux is determined by the container pressure P, and this situation is used in rocket propulsion. Next application of Bernoulli theorem is Venturi meter. which is used to measure the flow of speed of incompressible fluid. Venturi meter is a tube with a broader diameter and a small constriction at the middle. In this picture, a manometer of U-shaped tube is attached to the venturimeter. The one arm of the manometer is connected to the broader area capital A of the venturimeter, and the second arm of the manometer is connected to the constricted point of the area small a. According to the equation of continuity, the velocity at the constrict area will be higher than the broader area. Hence, the pressure at the constrict area will be lower than the broader area, which is shown in the picture by the manometer. The liquid level of the manometer is rise at the arm connected to the constricted area, which is evidence of the lower pressure at this point. That is basically venturimeter works on the principle of Bernoulli equation and continuity equation. As the venturimeter lies horizontally, hence the potential energy at each point will be 0. That is, here P1 plus half rho V1 square equal to P2 plus half rho V2 square. By applying the continuity equation, we get the difference between pressure P1 and P2 equal to half rho V1 square bracket A upon small a whole square minus 1. As here pressure is measured by the manometer, hence we can say that P1 minus P2 equal to rho mgh, where rho m is the density of the liquid filled in the manometer and h is the level difference in the manometer. Now we can find out the speed of the flux at white neck, and that is V1 equal to under root 2 rho mgh divided by rho and bracket a upon a square minus 1 whole power inverse half. Principle of venturimeter has many applications like carburetor of automobile, filter pumps or aspirator, Bunsen burner, atomizers, sprayers used for perfumes, spray, insecticide. In the carburetor of automobile, the air is mixed with the fuel using the venturimeter principle. In spray, as we press the pump, then the air speed will be high. As the speed is high, the pressure will be low and this liquid from the bottle of the perfume goes upside to balance the pressure. With the help of the Bernoulli theorem, we can explain the blood flow in the body and heart attack. Similarly, we can explain the effect of dynamic lift, which is a force that acts on a body by the virtue of motion through a fluid. Similarly, we can explain the spin and Magnus effect in ball or a spin of any object, how this Magnus effect is occur. Same way, we can also explain the airfoil or lift on aircraft wings, how the aircraft is flying in sky with the heavy body. So here some detail is here, so go through it and we will discuss in the next section. Thank you.